All right, everybody, up to this point, we've talked about magnets and moving charges applying forces to each other. Now we're going to talk about moving magnets. Yeah, that's all I'm going to say. Here we go. I don't want to ruin the fun. So what I got ourselves is a magnet here. Got some aluminum. There is non-magnetic. To prove to you it's a magnet. Okay. So it is a magnet. So what we're going to do is we're going to drop this through. So if I were to drop it, let's see, let's time it. Ready? 3, 2, 1, go. Let's go as fast. Right? All right, here we go. Ready? 3, 2, 1. Woo! That went slow. Let's do this. Let's flip this over and let's have it go. So before it had a north side going down, so now let's have a south side going down. Let's see what happens. Huh. So if I think about what's going on in here, if I have a north side down, is it okay to say that as it's moving, that somehow there's a north side going up? That somehow the charge, the electrons, spin in this, creating a field upwards. Okay, let's think about that. So this is called induction. When you have a moving magnetic field causes a current in a conductor. So next up, I got a very simple setup. This is it's a galvanometer. If I said that wrong, please don't judge me. It's going to measure a very small amount of current, but it measures current, microamps in this case. So what I have here is I have a magnet, and this side here is north. I didn't write on it, but it is north. This is north, and this is south. So I'm going to bring a north side in. Well, that's not the most beautiful thing you've ever seen, right? It barely moves. So we're going to up the number of coils. So here we've got, geez, I don't know, 10,000? Nah, maybe 1,000. So what I have is my magnet, and here's my galvanometer. And what we're going to do is I'm going to, how about this? I'm just going to just put it by it. Nothing. I'm going to put it near it. Nothing. But watch when it changes. I'm going to make sure you guys have a good view of this. Yep. Let's get that right there in your faces. Right there, right there. Okay. Did you see that as I put it in, do you see how it went positive? Let's do that again. Okay, ready? So hold on. I'm going to put it in. Had a positive current. Look what happens when I take it out. Negative current. If I flip this over, now the south is down. Watch what happens when I put it in. There's negative. Then I take it out. Positive. So the big idea on this is the electrons in the conductor here don't want to move. They resist change. But as you introduce a magnetic field, a changing magnetic field, right, because it's moving. There's nothing now, and it has now. It is going to change, and those electrons resist that change. And so how do they do that? They move. Because when electrons move, they produce a magnetic field. What is happening here is as these electrons have this changing magnetic field, as these flux lines come in and cross over them, they resist that change. So if I bring a north in, they will create a north going this way to oppose it while it's moving. Okay. We're going to get after this a lot more, but this is just an introduction. I want you to see the phenomenon. My hand crank. You've ever seen the hand cranks where you crank the dial and you can get it to light up? Well, that's the same idea here. When you do that, what are you doing? You're moving a magnet, and as you move the magnet, you get current. So a changing magnetic field gets you current.